Good morning to all my students. Dear students, today we will discuss and explain a very important topic. The topic will be under the theme magnification, and the second subtopic will be under the theme mirror formula, or we can say mirror equation. At the end of these subtopics, we will try to solve a numerical which will be very much beneficial for your upcoming exams. Dear students, firstly, we will try to learn the magnification. My dear students, let me pose you a simple question. Have you ever visited a circus or have you ever visited a museum? In the museum, you might have seen the mirrors which are attached to the walls of the museum, and you might have seen yourself in those mirrors and your image does not look like you. Sometimes the image looks fatter than the actual size of the body, and sometimes it looks smaller or thinner than the actual size of the body. Have you ever wondered, dear students, what is the reason behind this? What science is behind it? Dear students, physics gives the answer to this question. This is because of the magnification, which you will try to understand in this very important topic or important class. Dear students, let us try to understand what this magnification actually means. Dear students, as for the physics is concerned, physics defines magnification in two ways. The first definition which physics gives, the magnification can be defined as the height of the image, as the ratio of the height of the image to the height of the object. That is, it may be defined as the may be defined as the ratio of the height of the image, which will be represented by hi, to the height of the object, which will be represented by ho. And if we'll try to summarize this formula, the ratio of the height of the image to the height of the object gives the definition of magnification. And you must remember that magnification is usually represented by a small letter English letter m, and therefore m can be equal to the ratio of the height of the image, that is hi upon ho. That means the ratio of the height of the image to the height of the object gives the value of the magnification, and we will place this equation as equation number first. In the second way, the physics defines the magnification as the ratio of the image distance to the object distance. That is, we know that the image distance, that is when the object, for example, we will try to understand this image distance and object distance first. Let us draw a concave mirror here. This is the concave mirror, and this is the pole of the concave mirror. You know that this is the center of curvature of the concave mirror. This is the principal focus of the concave mirror. Dear students, if we will place the object between C and F like this, this is an object AB, this is an object AB, for example, object AB, and for example the image gets formed somewhere between beyond C. This is the image A dash B dash, for example. This is the supposition. This cannot be true. I am just trying to understand what actually V and U means to you. This is the image, for example. And dear students, the distance of the object from the pole of the mirror, this is the pole of the mirror, and AB is the object. This distance will be termed as the object distance, and it is represented by U. Okay, now this image distance, what is actually image distance? The distance of the image from the pole of the mirror. This is the pole of the mirror, and this is your image. So the distance between the image and the pole will be termed as image distance, and it is represented by V. Therefore, you might have got the concepts what actually U and V means to you. Okay, now I will rub this, and we will try to concentrate upon the definition number 2 of magnification. Dear students, or this is the definition number 2. It may be defined, this magnification may be defined in terms of object distance and image distance, as it may be defined as the ratio of the image distance. And you know now what actually image distance is, and it is represented by V to the object distance, and you know that now it is represented by U with a negative sign, that is M equals V upon U, but I have written here negative sign. You have to incorporate negative sign. This is the equation number 2. Now, so many students might have a doubt in their minds why we place a negative sign here. Dear students, it is very much simple. This negative sign is only because of the placement of the object. You know that object is always placed on the left side of the mirror, or we can say on the front side of the mirror, and whenever anything is placed on the left side of the mirror, we place a negative sign with that. That is why this negative sign is actually attached to the object distance. We know that object is always placed on the left side of the mirror, so this negative sign can't be denied. We can always place a negative sign here. So we can have the two formulas for magnification. M equals Hi upon Ho, and the same M can be in the form of minus V upon U. So if we combine first and second, let's try to rub this here. We can combine first and second. Combining first and second, we get that is M, and M is the same quantity, so we can write only M here, but here Hi upon Ho equals minus V upon U. So we can get this formula here. This is the equation number 3, which is the required magnification formula, or which is the required magnification which can be used in the numericals. Now we will try to move ahead to understand the mirror formula. But before going to mirror formulas, we can have so many cases which are usually asked in the examination in the form of MCQs, and this thing which I will discuss for 5 to 10 minutes. This is very important, and try to grasp everything in these 10 minutes. Dear students, let me write here the magnification, the two formulas of magnification first. M equals Hi upon Ho. This is your equation number first. Okay, and further we can have another formula for M equals minus V upon U. This is equation number 2 for magnification. On these two equations we can try to form almost 5 cases, and from these 5 cases at least 1 or 2 MCQs are generally asked in your exams. Dear students, if we will go with the help of this equation number first, we have M equals Hi upon Ho, and we know that Hi denotes the size of the image and Ho represents the size of the object. Dear students, if we will try to recall that the object is always placed above the principal axis, let's try to revise a little bit about it. This is your pole, this is your C, this is your F, principal focus and optical center. Dear students, if we will try to locate the object, it might be here, it might be at F, it might be between C and F, it might be at C, beyond C, and at infinity. But at every point you can see here this, and this, and the infinity case. At everywhere you observe that the object is always placed above the principal axis, and from the sign convention we generalize a concept, we draw a concept that the distance of the size is always positive when it is placed above the principal axis. This is the object placed above the principal axis at every cases, at every position object is placed above the principal axis, so Ho can always be positive. Okay, Ho can always be positive. But the image is formed of 2 types. Image can be of 2 types. Image can be of 2 types. It can be real, it can be virtual. Dear students, if it is real, so it is like this. If this is P, this is your C, this is your F. If it is real, it is always inverted. That means it will be inverted like this. So this is the real and inverted image. Okay, so if the image is real or inverted, we can say that Hi is negative. Okay, but if the image is virtual, like in the first case of the concave mirror, when the object is placed between P and F, the image format is virtual and behind the object like this. When the image is virtual, it is always erect. Erect means it is always above the principal axis. So we can say that when the image is virtual, Hi will be positive. So applying these 2 things over the formula number first, over the equation number first, we can have the magnification like this. M equals Hi upon Ho equals, for real case, if the image is real, we can have a magnification M equals Hi upon Ho. We have for the real Hi equals negative, so this will be negative. Hi will be negative, but Ho is always positive because object is always placed above the principal axis, so this will be positive. So negative upon positive becomes negative. So we can generalize a concept, we can grasp a concept that when our M is negative, therefore the image will be always real and inverted. Okay, now for virtual image, M equals Hi upon Ho. We know that Ho is always positive and Hi for the virtual case is always positive. So positive upon positive give us the result as positive. So we can generalize the concept whenever the magnification has the value, positive, therefore we can have an image which is which type? Virtual type. So we can have two things here to keep it in your mind. Whenever the image is real, then the magnification has a negative value. Whenever the image is virtual, we can have the magnification as positive value. These are the two cases. These are the two conclusions you have to keep into your mind. Now we have further more conclusions, three conclusions which can be asked in your exams. The conclusions can be as: dear students, case number third is like this. When the height of image is greater than the object, that is hi greater than ho, m can have the value hi upon ho. This is the formula. M equals hi upon ho. Dear students, case number 3, read it loud. When the height of the image is greater than the height of the object, that means numerator is greater than the denominator, like this, 3 upon 2. Numerator is greater than the denominator. We are saying here hi greater than ho, that is height of the image is greater than that of the object. What will the value of magnification? That will be, if we will see here 3 upon 2, it will give the value 1.5. That means it is greater than 1. This means that when the height of the image is greater than that of the object, the magnification has the value greater than 1, that is greater than 1. Okay, now we have the case number 4. When the height of the image is less than the object, that is hi is less than ho. So we can use again the magnification formula number first, m equals hi upon ho, and from the case number 4, hi is less than ho, that is numerator is less than the denominator. Likewise, as in the earlier case, we have kept is like 3 upon 2, but there is a reverse case. This is the negative case. As we compare this case number 4 to the case number 3, this can be written as 2 upon 3. 2 upon 3 is almost less than 1. So case number 4, whenever the height of the image is less than that of the object, that is hi is less than ho, we can have the magnification, and that value will be always less than 1. And you must remember, whenever the height of the image is less than that of the object, the magnification can have a value less than 1. And this is the case number 5. When height of image equals the height object, that is hi equals ho, therefore magnification can have a value hi upon ho. Also here, height of image and height of object equals, that is height of image like this. I will try to solve here. M equals hi upon ho, hi equals ho, m equals, so we can get the value hi upon hi. Why hi upon hi? I have replaced ho with the value hi, because hi equals ho. Hi will get cancelled out, and we will get the value plus 1. So we can get the value plus 1 here, and this will get cancelled out, as I have shown you here, because hi equals ho. Now we have these 3 cases to memorize. Keep it these three cases into your mind. When the height of the image greater than the height of the object, you can get the value of the magnification as greater than 1. And case number 4 is when the height of the image is less than that of the object, you can get the value of the magnification as less than 1. And case number 5 is when the height of the image equals the height of the object, you can get the value of the magnification as plus 1. Please remember these 5 cases. First case is real case, second case is virtual case, third case is height of image greater than height of object case, fourth case is height of image less than height of object case, and last one case, very important case, when the height of the image equals the height of the object. That means the size of the image and size of the object is same. And if I will try to draw your attention towards the concave mirror, we have a single case there where height of the image equals height of the object. Tell me, dear students, where at that point the object is located whenever the height of the image becomes equal to the height of the object. Dear students, that case is the case where this is very important, you must keep it in your mind because it may be asked in the exam. Case where the image size equals object size. You have to tell the case at which position the object is located, and then the image gets formed in which size of image equals size of object. The case is when the object is located at C, the image gets formed at C. That means in concave mirror, when you locate the object at C, the image gets formed at C, and in that case the image size equals the object size. So please remember this case in your mind because this may be asked in the exam. So this is the important generalization, or we can say this is the important drawing. Keep it in your mind, dear students. Furthermore, we will try to solve a numerical. This is a simple numerical upon the mirror formula and magnification. Numerical is very important and it has been asked in exams, probably 2018 NEET. This is very important numerical and have been asked in 2018 NEET. Numerical is an object is placed on the principal axis, of a concave mirror at a distance of 1.5 f, f being the focal length, what you have to calculate, the image will be formed at, the image will be, there were asked 4 options, and first is option number A is minus 3f, option number B is 15f, option number C is minus 15f, option number D is 3f. These options are given and you have to choose the right and appropriate option. Dear students, let's try to solve this numerical. First of all, let's try to read this numerical once more. We have the numerical, but dear student, this numerical is about the concave mirror. First of all, you have to judge which type of mirror is used in the numerical. Here it is a concave mirror, and whenever you observe it is a concave mirror, you have to keep it in your mind that focal length for concave mirror is negative. Object distance is always negative, but first thing you have to read it loud. The concave mirror has a focal length negative. Dear students, first of all, we have here an object is placed on the principal axis of a concave mirror at a distance of 1.5 f. That means the object distance here is 1.5 f. So here in the question we can use u for object distance, and it is 1.5 s, but I will place a negative sign with the object distance because object is always placed on the left side of the mirror. So is the case, I have placed a negative sign with 1.5 f. Now the focal length. What is the focal length of the concave mirror? F being the focal length. Therefore the focal length of the concave mirror is minus f. Because why negative f? Why minus f? Because we are talking about the concave mirror. We are talking about the concave mirror. That is why I placed a negative f or negative sign with the focal length. Now we can use the mirror formula to obtain or to achieve the target. What is our target? We have to achieve the target for the image where the image gets formed, the image distance. You have to calculate the image distance, and that image distance will be calculated with the help of the formula that is known as mirror formula or mirror equation, using mirror formula. And you know that mirror formula equals 1 upon f equals 1 upon u plus 1 upon v. Now you have to calculate the value of v. So what we will do, we will place 1 upon v equals 1 upon f, and this 1 upon u gets transposed, and it becomes 1 upon u, but negative 1 upon u. So 1 upon v equals, what is the focal length here? Negative f. So it will be minus f. In place of f we will put minus f. There is minus 1 upon u. What is the value of u? Minus 1.5 f. Okay, so these are the values that I have put in the mirror formula. Now 1 upon v gets equals, if we will see here, what we will do, we will do one thing. We will multiply this by 2 and this by 2 to get rid of this decimal, to ease our calculation, to make our calculations easier. What we will get? We will get 1 upon minus f. There is minus, and this is minus. Minus into minus becomes plus. 1 into 2, that is 2, divide by 1.5 into 2, that is 3f. Okay, so we have get rid of this decimal to make our calculations easier. Now this is very simple. So we will get it like 1 upon v equals, this is actually minus. I will put it minus here because so the case gets easier. 3f into minus 1, that is minus 3f, plus 2 into f becomes 2f, divided by 3f into f, it becomes. So we will do one thing. We will just get the LCM. 3f and f have the LCM 3f. Okay, LCM is the easier method. The LCM of 3, we will usually do one thing here. The easier setup is to get the LCM of the denominators. We have the denominators f and 3f. The LCM of 3f and f is 3f. So we can multiply here 3 and we can multiply here 3. So it becomes minus 3 plus 2. Okay, this is very simple. So we can get the value of 1 upon E equals minus 3 plus 2, that is minus 1 divided by 3f. Okay, now we can get the value of V, taking the reciprocal of 1 by V, that is V, taking the reciprocal of the right hand side, that is minus 1 by 3f, that is minus 3f. So our image distance will be minus 3f. That means the option A is the correct answer. So this was a very good numerical and have been asked in 2018 NEET, and this is very simple. But please try to understand whenever you solve an expression like this, firstly go for the LCM of the denominators. Like I have put here, the LCM of 3f and f is 3f, and proceeding like that, I have got the value of V as minus 3f, and therefore I can say that the image will be formed at minus 3f, which is the right and the appropriate answer. Thank you for your cooperation, and token is applaud from my side. Take care, all the best.